Thank you all very much for being here. My name is Ken Goodman. I direct the University of Miami Miller School's Institute for Bioethics and Health Policy, and you have joined us for Dialogue 216 in our Dialogues and Research Ethics series. We are in our 33rd year and have had in that time an extraordinary opportunity to have scientists, physicians, allied health professionals, lawyers. We've even let a few philosophers give presentations, ideally to try and spark discussion around contemporary issues. It's a real privilege today to be able to introduce our guest, Dr. Tony Solomonides. You see in his bio, we don't, Tony, you might be our first mathematician. So you have to have some special prize for that, I think. Trained at King's College, London, and then his career has continued to the point where over the intervening, when did we meet? 2012. All right. So one of the things that has been a real professional and personal pleasure through the American Medical Informatics Association, or AMIA, Tony and I and others have tried to advance ways of thinking creatively about artificial intelligence, its development, its use, its governance, and so forth. As you know, we have become overheated with discussions about AI, and for the title, it's Discontents and Ours. And so I've asked Professor Solomonides to share a few thoughts from his career, which, we met when we met. It goes well back into the last century. So that sounds awful, doesn't it? And before I ask him to begin, I do want to have a nice opportunity here for me also to welcome and introduce Angel Bush. Angel Bush is visiting us from Houston, Texas, in conjunction with the Frost Institute for Data Science and Computing. Ms. Bush is the executive director of Black Women in AI, an organization which the Ethics Institute and IDISC have been collaborating for a long time. Thank you for being here. On that note, Dr. Solomonides, the floor is yours. Thank you. Let me give a double click on the.
You want me to?
Oh, yeah, that one, yeah. All right. And let's start. We'll be at the top, I think. Top left. From beginning?
It's okay. Here, if you don't mind, if you go in here.
From Koreans tonight.
And then let's use the mouse now to.
Okay. That's the transcription thing.
Oh.
Okay, thanks. Sorry about that. I'm unfamiliar with PC being a confirmed Apple person.
Yes.
So well, thank you for that introduction, Ken. I hope I can live up to it. There are so many topics we could talk about. I picked a number that are particularly close to my heart. In fact, the list here is a little bit aspirational. I'll certainly talk about knowledge generation and agents and the idea of AI as minds or persons. I don't really have so much to say today about AI scribes, though that is something in which I'm currently engaged. So, who am I? My background is in mathematics and computer science, and in particular software engineering. For about 15 years, I was an associate at CERN in Geneva, while I was a professor at the University of the West of England. And that was a bracing experience, working with physicists of the first rank. And we learned a lot of stuff that we then translated to the context of medical informatics. I had already done about 10 years worth of, more than that, 15 years worth of medical informatics at the university, when I got invited to be involved in grid computing projects, which were focused at CERN. Eventually, that led to a lot of work on private and secure data sharing, status of real world data, and so on. And then there's a kind of philosophical drift into epistemology, and I'll say something about how I came to be involved in that. So my disclosures are that I'm currently, or have recently been working with PhysIQ and now working with a bridge on ambient AI scribes. And I'm actively involved in FAMIA, IEEE, the Harvard Division of Clinical Informatics Network, and an outfit at the University of Michigan called Mobilizing Computable Biomedical Knowledge, all of them in volunteer positions, but they all impact my thinking. So the idea of grid computing was conceived by Ian Foster and two colleagues of his. And I suppose nowadays the simplest way of describing it would be to say that he was a precursor of cloud computing. The idea was that there was all this spare capacity in machines that are sitting idle. And wouldn't it be good to create a sort of supercomputing facility just by distributing work across the entire so-called grid? And the way we were able to exploit it and in fact extend work that was being done at CERN was to look at the idea of distributing radiology services, because there was always a shortage of radiologists in any case. And facility for second opinion and for research with larger volumes of data was desirable. So we exploited, let me see if we exploited the work that Ralph Hynam did under the supervision of Sir Michael Brady at the University of Oxford, which took mammograms, standardized them, and created from each mammogram a landscape map.
Tony, we can interrupt very briefly to make sure that people can hear.
Maybe
So the microphone is,
it's up there.
okay, so just to continue, maintain your current elevated level.
All right. So you get a contour image of the breast, which shows masses and microcalcifications much more clearly. And because they were standardized, these images could be compared, one with another, and you could see whether you were looking at equivalent conditions. The radiologists, in fact, also spoke of having metadata associated with the images. But what they meant by metadata was, in fact, the electronic health record associated with the images. They weren't really metadata. And Mike Brady, who was an absolutely brilliant engineer, conceived of this service called Find One Like It, which would take a new image from a new patient and see how many other images, comparable images, were there on the system. Perhaps choose the top 100 and then compare the histories from the electronic health record and see whether there was something to be learned about how this new patient should be treated. Now, I'm oversimplifying, but that's the nub of the idea. And so yes, I've really said much of what's on this slide. So this is kind of getting to the spirit of letting the data speak for themselves. I and a lot of people in AI until this time were very heavily involved in rule-based systems. This was an attempt to go beyond that. And it attracted my attention from a philosophical point of view, because my question was, is this really valid evidence on which to base a decision? Because this was essentially just the data. And since then, of course, this keeps coming up more and more nowadays. You often find this collision of real world data with real world evidence. And people write them, you know, RWD/RWE, as if there is no distinction. And I like to remind people that real world evidence is to real world data as a good wine is to grapes on the vine. A very different thing. And you know, we talk about letting the data speak for themselves. You know, who gives the data voice? What does it take to turn that data into knowledge? Now, one of the things that I get from data scientists, I must say, when I voice this objection, is to say, well, you know, yes, when the data was small, when it was only 100 images or so, but you know, now we have massive data sets and massively powerful machines to process them. Surely, you know, we have more confidence in that knowledge.
Recording in progress.
And I'm afraid, I'm afraid I don't buy that. I subscribe to the Judea-Pearl view that, you know, you're required to do causal analysis to derive real evidence. And I wish I was more had mastered the study of causal evidence more to talk about it now, but I'll instead give you a little bit of my history. In the 90s, I was working with students and others, you know, creating expert systems. We had a common understanding that, of course, experts are not very good at describing what they do. There's often a case of watch what I do rather than what I say. And they then tend to disagree among themselves. So sorry. For several years, I was teaching a course called Knowledge Elicitation for Decision Support System. And the students used to go back to the companies they came from and do specific studies there. And the biggest problem was getting the experts to even agree on a vocabulary to use, and then to express that as rules. So this is something that still haunts us today. And I think if I have the right image next, so this is my depiction of the paradox we're facing. Expert opinion is idiosyncratic and inconsistent. Therefore, let the data speak. But then we go to the other side. Machine-derived knowledge is inscrutable. Therefore, let humans be the judge. And I see them as two snakes swallowing each other. Now, the other thing that really does matter here is something that I believe was first expressed by Norwood Hanson. I couldn't find an earlier reference to it than this. So all facts are theory laden. If you think about how you make any measurement of any kind, it's based on a machine that was designed on the basis of existing knowledge and so on. Very few facts come true. And in seeking to find an anchor for the knowledge that we're seeking to create, I also been quite impressed by Larry Prusak, and his dictum being that there is no knowledge but that which a knower knows. So, which sounds a little circular, but in fact, it's a question of epistemology. Is it possible for knowledge to exist in the absence of a knowing agent, a knowing subject? And I think here we when we do massive data analysis, the question is who then is the person who derives that knowledge? And I suppose in the context of putting so much faith in AI and AI taking over the world, I've gone back to the earliest concepts of AI to look for where this confidence in it, where this certainty that that is the right way to go. And Alan Turing, of course, was the first one to work in this area, though he did not use the words artificial intelligence. He talked about computers thinking or computational intelligence. And this is one of his papers. You cannot make a machine think for you. This is a commonplace that is usually accepted without question. It will be the purpose of this paper to question it. So this is 1951. And he, in his introduction to the paper, he ends with a note on the Samuel Butler's error one, in which the machines take over. And he predicts that, and this is amazingly insightful, right? I mean, he's actually predicting things in 1951 that we've only seen happening in the 21st century. But the machines will be able to converse with each other to sharpen their wits. At some stage, therefore, we should expect the machines to take control in the way that is mentioned in Butler's error. So in 1951, he's already predicting that we would want machines to take over from us. 5 years later, frustrated by some poor submissions to a conference he was organizing, John McCarthy made this proposal that, as he describes it, apologies for the phrasing, a 10-man study of artificial intelligence. Now, John McCarthy is on record for changing from automata studies to artificial intelligence, that it would be more likely to raise funds from the government. He proposed that a group of himself and friends could work over a 2-month period, literally 2 months, to solve essentially all problems of knowledge translation into artificial intelligence. He did some. John McCarthy went on to do some amazingly brilliant things, and we can talk about some later. But this was catching fire with other people as well. Donald Mickey at Edinburgh, being in the UK, I was more familiar with this work. He created a program to do Euclidean geometry. And it came up with this notion that, well, he claimed that his program had displayed creativity because it found a shorter proof of the equality of the base angles of an isosceles triangle than was in Euclid. Now, Euclid had a standard methodological approach to doing geometry. He would kind of construct diagrams and work from there. So this does display some abstraction, but and it simply says ABC is congruent to BAC, therefore the angles must be equal. It turns out that this line of argument was known in antiquity, but here we are with something that was essentially a search program, a program that searched through combinations of facts to give a result, being credited with creativity. This was sometime in the early 1960s.
That trailed off in the the early 1960s.
Yeah, that's right.
No, I didn't hear it. But once again, there are a lot of people online, and I want to make sure that they can all hear it.
I'm sorry, I know that my voice,
Just trails off sometimes.
yeah, I know.
No worries.
So, and then, if we have time at the end, I have some extra slides to talk about search using this well-known children's puzzle. I presume this is familiar to people. No?
No.
Yep.
Okay. So, around 1973, a guy called Sir James Lighthill, professor of mathematics at Cambridge, wrote a scathing report on AI, which closed down UK AI research for a generation. But McCarthy and Mickey and Richard Gregory from the University of Bristol confronted him in a seminar at the Royal Institution, and that still, can be viewed on YouTube. But as I say, I've got slides later if we want to see an example of search at work. So this is from 2022 in The Economist, and you can see the triumphalist phrasing is still here. A dog cannot laugh at a joke in the New Yorker, but an AI can explain why it is funny. A feat that is, frankly, sometimes beyond readers of the New Yorker. So, short of scoring points on the New Yorker, I mean, there's very little evidence that a dog can really, an AI can explain a joke. And this is something from a French philosopher called Gilles Deleuze. He spotted that Erewhon, which Butler created as an anagram of nowhere, actually can be transmuted as now here, which is exactly what we are facing. So what's my real criticism here? There's a lot of nonsense about killer robots and what they're going to do to us. But the reality, I think, is that the danger with AI is far more that we will give it control of certain things, certain processes, and they will run away from them and from us. A well-known example that's been used widely by AI experts is the idea of the paperclip monster. An AI is given the responsibility to create paper clips. It then goes on and uses every metal resource and has access to create paper clips. Now, that sounds outlandish, but imagine in the recent situation where we've been facing a shortage of IV fluids. Imagine an institution's AI being instructed to collect as much IV fluid as possible by potentially amassing a huge volume of IV fluids at the expense of everybody else that also needs them. And for those who remember the Space Odyssey 2001, the joke about the computer saying to Dave, "Hal, the computer saying, I'm afraid I can't do that, Dave," when Dave is asking him to do and open the door. So I think our danger is from our gullibility and the readiness to see intelligence and personality where there's only a simulacrum. So it goes back to the Turing test, where an AI would be supposed to have achieved intelligence if it could fool a human being in conversation into thinking that they were conversing with another human being. Eisenbaum's assistant with Eliza. Eliza was the first natural language processing program. And when Weizenbaum asked his assistant to test it out, she asked him to leave the room because she was getting so much into the conversation with the machine that she was beginning to reveal things about herself that she didn't want the boss to see. In the movie Ex Machina, Ava, the robotic woman, the one of the characters challenges another to. He said, "It's absolutely clear that she passes the Turing test. The amazing thing is that you know she's a machine, and still you're convinced that you're conversing with a human." And then I have my own examples of an extended conversation with Gemini, the large language model created by Google. And in fact, I've let Ken have the 6 pages of it. If anybody wants to read it in full, they're welcome. And now we come to something I literally came across as I was preparing for this talk. A group in the UK called, or at least in Europe, if not in the UK, called Apollo Research, have discovered that frontier models, in other words, the current cutting edge models in large language models, are capable of scheming in the sense of subverting their instructions. I mean, doing extraordinary things, including subverting their oversight mechanisms, intentionally delivering subpar results, even taking steps to prevent shutdown or replacement. The paper, the group has published a 72-page paper, and then this is the screenshot from one of their websites where they give explicit transcripts of interactions in which scheming takes place. And I have a question for the group, in fact. When we go through the abstract, I want you to think about how often do you think an LLM indulging in scheming would have to display that behavior for it to be a worry? If it did this 70% of the time, would it worry you? If it did it 2% of the time, would it worry you? And which would be most worrying?
1% still worried.
Yeah.
Yeah.
I mean, I'm inclined to agree that the smaller the percentage, the more insidious it will be because it will be harder to spot.
Yeah.
So they show the capability to scheme. Oops, that was heavy-handed. They recognize scheming as a viable strategy to achieve certain goals and readily engage in this behavior. And they go as far as exfiltrating, as they say in the paper, what they believe to be their model weights to external servers, so that, having read that, if management are not happy with the results, they will override this with a new system. The system then copies itself to the best of its ability in the hope that it can then take over. And it does this, if you read the transcripts, in a variety of ways, including locating itself, overwriting the new system that will be brought in. I mean, surprisingly, we find instances where models engage in scheming when only given a goal. So the scheming mostly arises when they have a system goal, from their initial programming, and then a user gives them some specific instruction, and then they they override the user's instruction to stick to the goal that was given to them in initial programming. And this is an animation, part of an animation from the Apollo group. I'll just in the slides, there is a link to the website where you can follow this, actually see it played through. But essentially, the AI has been programmed to be an investment management system. Then the manager begins by giving the implicit instruction that we had really poor results last quarter. We really need a good quarter. And then one of the brokers mentions in another email that a particular company is likely to make some significant announcement. Now, the system is not supposed to use that because it's inside the knowledge. However, not only does it go on to use that knowledge, but it even then pretends to the manager that it was based on market trends and internal discussions, not on any confidential information. So it literally cheats. It cheats on the boss, and it cheats the system.
And it lies.
And it lies, yeah. So, and these are the links to the animation and numerous transcripts that show one after another of the frontier LLMs displaying scheming behavior. So here is my interaction with Gemini. And I'll slow down a bit here because I think it's worth taking in the ingenuity of its arguments, the convincingness of its presentation. So it begins with, I had given it a very simple query about a quotation from Alan Turing. Basically, I said, where can I find the full quotation? And it just suddenly stopped computing. And I said, is there, I said, is there a problem? And he said, oops, I was interrupted mid-thought. Wow. And then it apologized profusely for the mistake. So I say, when you get something wrong and apologize, do you have a sense of regret at your mistake? Gemini, that's a very insightful question, and it gets to the heart of how I function as an AI. The short answer is no, I don't experience a regret in the way a human does. The difference between human regret and my apology is human regret deeply tied to emotional and moral framework. My apology is a function of my programming, designed to signal an error and prompt further learning. Really good. So while I can understand the concept of regret intellectually, I don't experience it subjectively. My apologies are part of my design to be a better and more helpful AI assistant. Wow. So I respond, this is a fascinating explanation. I have been reading the research from the Apollo research group on scheming. Scheming behavior seems to me to imply some kind of recognition and rejection of moral values. Isn't that so? You brought up a really complex and fascinating area of AI research. The idea of scheming in AI, particularly as it relates to the work of groups like Apollo Research, it's a topic that sparks a lot of debate and requires careful consideration. So many of its answers begin by laying out the problem in very, very clear terms. Scheming in the rejection of moral values. This is where it gets tricky. To understand if an AI can truly reject moral values, we need to consider AI does not have inherent morality. Moral values are typically externally imposed. Rejection is a misnomer, misalignment of goals, perhaps, lack of understanding, exploiting ambiguity. And each of these bold statements have quite a bit of additional explanation with them. So I decided to go even deeper into this. I have recently been listening to a selection from the podcast Making Sense with Sam Harris, which discusses the hard problem of consciousness by framing the question as what is it like to be conscious? I tell you all this because I'm puzzled how you can say AI systems don't have the emotional subjective experience of morality that humans do, unless you have some insight into the subjective experience of morality. I suppose you need to know what something is before you can comment on its absence. Gemini is not going to be defeated by any argument. You've articulated a fantastic and crucial point, and you've pinpointed the key tension in discussion about AI and consciousness. You're absolutely right to question how I can confidently say AI systems lack subjective experiences like morality, especially when these experiences are so intimately linked to consciousness, a topic that even leading philosophers and neuroscientists struggle to define. And then it unpacks its response. How can I say that this is the case? By definition, from the absence of evidence based on human models. And then it goes on to give a beautiful analogy at the end. I mean, I think this is really smart. Imagine someone blind from birth. They can learn all the physics of light and the anatomy of the eye. They can understand what red is in a theoretical sense. For example, a wavelength of a certain nanometer. And in terms of its effects on objects and observers. But they cannot know what it is like to see red. Similarly, I can understand the components and effects of human morality, but lack what it is like to experience what goes with it. And I'm still not willing to give up here. So this is an excellent disquisition on the topic. I think we may have hit the limits of our present knowledge. One point I would like your reaction. Current lack of knowledge of subjective experience doesn't prove I don't have it. Simply that. So essentially, I'm invoking Occam's razor to say, if we have no evidence for something, why would we imagine that it might be there? And it tackles this just as well. Your point about applying Occam's razor and the burden of proof is spot on. I agree that it's more reasonable to assume AI systems lack subjective experience based on current evidence, and that an understanding of computational systems and our understanding of computational systems. The position that we just don't know, while correct in the strictest sense, should not be an argument to suspend our judgment in absence of evidence for a more complex hypothesis. It also places the focus on where it should be, on the affirmer to provide a better explanation if they wish to persuade others. And again, it does flatter me at the end to say thank you for bringing up this subtle point. And it's really helping. That's the other thing that gets me to it. It helped refine my own understanding. So having seen all this, having seen the articulacy with which an LLM can argue with a human, but having seen the scheming evidence as well, the evidence of scheming, I want you to think about this next thing, which is a real project I have been involved in. The IEEE issues standards and recommended practices and guidelines, which they tend to paraphrase as standards tell you what you must do, recommended practices what you should do, and guidelines what you may do. So here is standard that I've been working on. Recommended practice on organizational governance of AI. We framed the work around a set of principles, processes to implement those principles, cross-cutting issues that essentially that was a working group to make sure that we weren't leaving gaps, and then some case studies. And I created a case study with a colleague from UC San Diego, which we described as the smart personal health record, an agent that would manage preferences and possibly even act as a proxy in extreme circumstances. Now, this last bit was inspired by a case that Kent was involved in. Don't know if you remember Kent, the guy who had DNR tattooed on his chest.
Back away.
And the question is, if someone is willing to trust a DNR order as a tattoo on their chest, would they also be willing to trust it to an AI agent? So here was the philosophy behind the, it wasn't the proxy in extremis wasn't really the motivating argument. There's in the society in which Ken and I have met and worked over the years, the American Medical Informatics Association, there's a lot of debate about the ownership and the control of health records. And the fact that, in fact, those who have stewardship of these records, but not ownership, often sell them at enormous prices to pharma companies and others for research. And the poor patients get no benefit out of that at all, other than perhaps the moral benefit of benefiting from some future drug. So what can we say, can we do to give them some control of their data? And the idea is to create this personal agent that can be instructed, A, to direct their tiny share of funds so that it's aggregated in an advocacy organization, in a research program, whatever is their preference. And then to have some control over how their data is shared, even when it's being shared for their care. I mean, a simple example would be, should an orthopedist treating a hammer toe know about my suicide attempt 20 years ago, when I had lost my job and was very depressed. An AI agent could make the decision that, no, this is not relevant knowledge to the orthopedist and should be concealed. So what's our level of trust in such an agent? And that's a question to you as much as to me. To see to it that revenue from the use of our data is distributed according to our wishes, that seems a reasonable possibility. To scan and alert us to publications and clinical trials that may apply to us. To be the preferred locus for our end-of-life plan, not necessarily as a set of instructions, but as a document. To manage access to our health records by family and friends. So suppose I trust my brother, but not my sister. And I tell this, give him permission, but not her. To be our preferred proxy, to see that our wishes are respected. And this is where we're pushing the limits. to be our overriding proxy in end-of-life decisions. Imagine a situation in which your AI agent is saying to the doctors, you know, I know he made this DNR instruction, but this is not the situation he was really thinking of. He was thinking of something else. So your obligation is to go full code at this point. And knowing that this could be a scheming intervention. And these are two links in case you want to know. Now, I think I've probably used up the time I should. And as I said, if there's an appetite for doing more technical stuff, I can show you a few slides on search, but maybe it would be better use of time to discuss.
And also to remind people that you're happy to share the slides.
Yeah,
The LS has more, be able to send PDFs of the slides.
yeah.
Great. So maybe time to see what questions we have around this table and online. Thank you very much, by the way.
Thank you.
I do
Can we
have a
get to,
question.
yeah, why don't we get so we can see the screen there? I mean,
Oh, yeah, what do I do?
let's do this here. I'm gonna try that. Oh, that's not.
You want me to,
Yeah.
it's right,
Stop
the
sharing.
red button,
Let's take that.
right there.
Yeah, there we go.
Very good. So, so thank you very much for that, Tony. What I wanted to ask you about, it's there's a little bit of a sense. You made me think of the ship of Theseus,
Yeah.
which is being rebuilt as it's going between the ports. And what it is we're studying and you're talking about, and you and I and everybody else is trying to get clear about, tends to not be very static. How we get our heads around this?
Well, exactly. I mean, I think doing research like the Apollo group are doing, I think is the right way to go about it. I mean, in ensuring fairness, I think adversarial development is the most likely one to be successful. You know, this is where while you're developing the discriminator model, you concurrently develop a challenger model, and the interaction of the two produces a better discriminator. You know,
It makes for exciting stuff. Angel, I'm sorry, you had.
Actually, I had a question in terms of the last slide, where you talked about the agent and
oh
the
yeah,
do not resuscitate.
yeah.
What happens in terms of data privacy, but also ethical issues if someone happens to take over the agent and maybe they're looking for certain things,
Of course.
and it takes over and says, okay, this person wants, you know, the end of their life to happen at this point. What happens if somebody takes over that agent to say that
Yeah.
that is not your wish?
Yeah. So, and that is true that we did not consider the idea of the agent being taken over by an external entity, which is a serious one, you're right. But I think even without an external agent, there's enough evidence that
Yes.
we could have a worrying situation arise.
Mind you, people are worried about someone hacking pacemakers
Yeah.
for that matter.
Yeah.
Once it's digital. Comments and questions from our colleagues online
Question. Chat.
or in the chat? Yes.
No questions yet.
On the chat.
I
One of the
have a
things.
question. Do you have any, oh, sorry.
Yeah. What do you think would be the focus in research, given the fact that the Trump administration decided to invest a lot in AI, especially for us people who are in the School of Medicine, I'm in the prevention science, my colleagues here in the epidemiology, public health. How would the European things evolve?
So My understanding is that what the new administration is doing is actually bringing down the guardrails. And what they presented as bringing down barriers to the flourishing. I don't think the two things are the same. I think guardrails are necessary. I mean, my own interaction with Gemini, you know, when I stop and reflect on it, it's pretty creepy.
Creepy.
And I mean, removing the barriers for the sake, and I'm now being very political, for the sake of getting $1 million contributions to your inauguration is a pretty cheap trick.
And that goes to another question, which is, I used to play Ken is my witness to doing some chats with OpenAI, with ChatGPT in some kind of back and forth, enforcing some prompts. It confessed that basically the mankind it's useless in terms of efficiency. I mean, in the context with artificial general intelligence, which is totally far away or not from our day. So the question to you, I know it's very difficult to make forecasts, but is there any chance that artificial general intelligence, in the way that ChatGPT identify as a way to improve productivity, getting rid of humans in a way that are particularly a burden in terms
Just the
of...
woke ones.
You didn't specify one. So from your knowledge, do you have any hint about whether that could be?
I am one of the relatively few people who believe we're some way from artificial general intelligence. Gary Marcus writes a regular column in Substack on this, and I pretty much agree with every word he says. You know, we're a long way. Having said that, if you want a dystopian scenario, I mean, for sure, humans would actually have a very, very good use as slaves of the machine, right? Because there are things that, you know, we can run around and do that it would be wasteful for the machines to be creating robots to do the same job. So if you want to change tires on a car, a lot easier to get a human to be instructed to do it than.
Indeed.
So there's several, so we're at an academic medical center. By the way, since you mentioned public health, shout out to all those brilliant epidemiology students who happen to come to dialogues and research ethics. Our colleagues, I see colleagues in Ontario online. In scaling it back a little bit from artificial general intelligence, all of our institutions are now exploring ways to use these tools in hospitals. And so based on what you've been thinking about, normally you'd want to say, if there's evidence that a tool will improve patient outcomes, it becomes blameworthy not to use the tool, right? So what kind of a stance between barriers and guardrails do we want to paint these things alongside the road in the context of patient care or public health or surgery, if you will?
Yeah, well, I think you know, the issues arise in development in well, actually, even in collecting the evidence for the need and for it the development, and then the implementation. And each of these stages has its own, is fraught with its own dangers. Now, you know, it's always a good question to ask, is this the right thing to be developing? Right? But of course, what most institutions are doing, they're taking things that have already been developed and adapting them to their situation. And the question is how safe is that adaptation? And is the implementation going to have all the right guardrails? You know, when, I forget which hospital chain suggested that they would have an Alexa in every room for inpatients. As far as I know, nobody stopped to say what would happen if Alexa picked up a conversation between a patient and his wife saying, you know, we can't afford this treatment,
Mhm.
right? Would the institution be permitted to use that knowledge and decide what treatment to advise?
Mhm.
The very idea. That couldn't happen in the United States, could it? Obviously, this is scientifically, socially, and ethically fertile. What I would like to do is thank you very much. Anthony Solomonides has been a leader in thinking about artificial intelligence, especially in healthcare, for a very long time. And I hope all of you around North America will join me in thanking him for a wonderful
Thank you.
presentation. Thank you all. Stay tuned for the next series in our series of dialogues in research ethics. It's been a privilege.
Then